distance time graphs. So distance time graphs are graphs that show the distance traveled relative to the time. Now, the main feature that describes distance time graphs is the gradient, and the gradient is also the speed. So if I'm given a distance time graph and I want to find the speed, simply I need to find the gradient first, and then I can equate the gradient found to the speed. Now, if you look on the right, so we have a distance time graph. And this graph is made up of 4 stages, A, B, C, and D. Now, let's consider first the first segment or the first stage, which is A. Now, for A, the line is going up, which means that the gradient is positive. So here, the speed is positive and it is constant. Now, for the second stage, B, now the line is a horizontal line, which means that the gradient is 0, which means that the speed is 0. So the particle or the car here is at rest, the speed is 0. Now, the third stage, which is C, again, the line is going up, which means that the gradient is positive and the speed is positive and it's constant. While the last stage, which is D, the line is going down, which means that the speed is negative and of course the gradient is negative. Now, in this example, I'm given a distance time graph and that shows a car's journey, and I want to find in part A how far did the car travel in the first 3 seconds. So in the first 3 seconds, so the car traveled, so here is 3 seconds. So at 3 seconds, the car traveled 60 meters. So the answer to part A is 60 meters. Now in part B, it says for how long was the car stationary? So by stationary, I mean that the car is not moving or the speed is 0. So whenever we have a horizontal line, this means that the gradient is 0, which means that the speed is 0. So for how long, it's basically the difference between 4 and 6. So 6 minus 4 is equal to 2 seconds. So the car stayed at rest for 2 seconds. Now in part C, it says what was the car's greatest speed. Now again, we said that the gradient is equal to the speed. Now, if I want to find the greatest speed, this is basically the steepest line. So I have this line, or this line, or this line. So which line is the steepest? It's of course this line. So this line represents the greatest speed. Now to find the speed, I need to find the gradient. So which is equal to y2 minus y1 over x2 minus x1. So let's pick 2 points. So the first point is going to be 8 on the x and 180 meters on the y. And the second point is basically here, which is 6 on the x and 80 on the y. So let's find the gradient. So y2 minus y1 is basically 80 minus 180 over x2 minus x1, which is 6 minus 8. So 80 minus 180 is negative 100 over 6 minus 8. It's not 6 minus 2, it's 6 minus 8, which is negative 2. So negative 100 over negative 2 is equal to 50 meters per second. So that was the greatest speed. Now, in part D, it says what was the car's average speed for the whole journey. So average speed, it means the total distance over the total time. So the car traveled first 80 meters, then from 80 to 180 it's 100 meters, then from 180 to 220 it's 40 meters. So that's the total distance over the total time, which is this reading, which is 10. So 100 plus 80 is 180, plus 40 is 220 over 10, and the answer is 22 meters per second. So the total distance is simply the greatest y reading, because the graph stops at 220 meters, and on the x it's 10 seconds. So 220 over 10 is equal to 22 meters per second.